Okay, so this is the next one then. This is the transonic flow over the same aeroform, except using the overset mesh. And yeah, this one shows how to change the angle of attack without having to generate a mesh. So you can use this one to change the angle of attack of aerofoil. You can also use the other one by changing the, like we did before, you can change the Cartesian reference frame to change the angle of attack. So two different ways of changing the angle. So let's go through this one. So import the geometry. Let me just close. I'm just going to close this one down. Oh, right, let me do it. Just get rid of all that. Let's start it up again so it doesn't confuse it. And then when that opens, we're going to load a file. So file load. We click OK to that. We've got to browse. We're going to find the file, and that's in the same place as before. So C drive, program files, city code, top one, third one down, DOC. Oh, wrong one. Let's go back up. DOC. Start tutorials. Data compressible flow. Data. And it's powerful overset parts for this one. Right, okay. Click OK to open it. There we go, I think that's opened. And then you've got to save it. File, save as. Oh, okay, put it there. Let me put it somewhere else. Okay, that will do. Put it in my document. So put it wherever and save it wherever you need to go. So next thing then, I'm in so create and define regions and boundaries for the domain. First, assign the background and overset parts to regions. So this will be the geometry, I think. So this is what we've imported. Multi-select the background and overset parts. So shift. Oh, hang on. So it's control background overset. Right click. Assign parts to regions. And then we're going to create a region for each part and create a boundary for each part surface. Okay, I think that's okay. And then click apply, and then just click it once and then close. And then you go into the regions. This is what we've just created. We've got a background and an overset. And we want to to background, boundaries, and then it's saying select the outside node and set the type to free stream. So we're changing that from a wall to free stream. And the next thing, repeat this procedure for the symmetry boundary. So set symmetry, change the wall to symmetry plane. Okay, and then for the overset boundaries node, we want to set the airfall as a wall. That's already a wall, so that's okay. The overset boundary, we're changing that to overset mesh, and we're changing the symmetry from a wall to a symmetry plane. So this is usually like the background mesh, and then this is in the foreground, and then we've got this overset boundary that links the two. Okay, there we go. Let's get that out of the way. Okay, so that's okay. Next thing, prepare the meshes. So set up background mesh. So we right click geometry operations. New, and then it's automated mesh, but it's new mesh, automated mesh. That comes up with this dialog. Select the background on the parts mesh and select the following meshes. So we want the surface remesher, we want the trimmed cell mesher, and we want the prism layer mesher. Rename, and then I think, let's get that out of the way, and then click OK to that, I think. Rename operations, okay, and then we want to rename this automated mesh. Right click, rename, and we're gonna change that to background mesh. Background mesh. So you can name it whatever you like. Background mesh. Edit this operations, default controls, and set the following properties. So there's all these different things in there which you can edit. The base size, we want to change that from 1 meter to 0.5. Let's return to enter it. Minimum surface size, changing that. 25% of the base. And then the volume growth rate, default growth rate, we're changing that to slow. So this is how the volume mesh grows outwards. And the surface growth rate, we're changing that one to slow as well. So there's a surface and a volume growth rate. The next thing, right click, operations, background mesh, that's the default controls. So custom controls, set new volumetric control, and then if you expand that out, got this new volumetric control in there, and we edit that. So in the parts, want to select the overlap. Click OK. And then in the controls, we are selecting surface remesher. We're activating that. In the trimmer, we're activating the customize isotropic size. And then in the values, percentage of base, we're going to change that to 12.5. Okay. Okay, so that's that done. Now we're going to set up the overset mesh. So copy and paste the background mesh node into operations. And rename a copy. So right click that, we can select copy, and then right click that, paste. You just there we go, top round of the background mesh, and rename this to the overset. So this will have everything of what we've got in there, just all copied straight through. And I'm going to rename this to overset mesh. And then I'm going to edit this slightly, so we're going to go into the overset mesh. I'm going to input the parts, select operations, overset mesh node, we've got that. Select input parts to overset. So input parts, we're going to select to overset. I think we've got to take off the background. It doesn't say that. Let's leave it in there for now. See what happens. No, let's deactivate the background. No. It doesn't say to delete it, so let's carry it on. Numbers node, set the input parts, set overset, set the operations, overset meshes. Let's click OK to that then. Actually, no, I want to do that actually because I think it might mess it up. So I'm going to deselect background. Okay, so that's just selected to overset now. Set the operations, overset meshes, prism layer, and set the distribution mode to wall thickness. So change the depth factor to wall thickness. And then we got operations, overset default controls, and we're going to change those according to this table. So the base size is the same, that's okay. The minimum surface size, that should be the same, it's copied across. The number of prism layers, I'm going to change that to 15. 15. And the volume, that should be the same, the volume growth rate, and that's all copied across, okay. The prism layer near wall thickness, this one, we're going to change that. 1 centimeters 4, we've got 1 centimeters 2, a couple of zeros in there. And then want us to rename the custom, rename the operation overset custom controls to overlap. And you'll notice you won't be able to rename the custom control, it's actually the volumetric control that you're renaming. And that's called overlap. Okay, expand that one out. Right, Okay. Let's do that. So we're creating three new additional volumetric controls and giving them the following name. L4 leading edge and trailing edge. So new volumetric control. I'm going to do that 3 times. New volumetric control. New volumetric control. Okay, so there we go. I'm going to rename that one to airfoil. Oh, hang on a minute, have I done that in the right place? Okay, I think I've done that in the wrong place. Where am I? I'm in the overset. I think I might need to be in the background. Let's carry on anyway. Not very clear. So rename this one. Rename. Leading edge. Rename. Trailing edge. Okay, in the controls mode of all 4 volumetric controls set the following properties. So we've got load, control controls, surface remesher, custom size activated, trimmer, custom isotropic size activated, yes, and that should be the same for all of them. Oh no, it's not. Okay, so I've got to add those then. So, and then custom isotropic size. Okay, so let's activate those. I'm going to do that for these one as well. So let's activate. Oops. And this one. Okay. Right. Each volumetric control set the following parts and following values. So for the overlap, the parts is the overlap, which is okay, and the percentage of the base. Where is the percentage of the base? So we've got the parts. Overlap, that's okay. Volumetric control. So we've just got to find out where this. I can't find out where the. It's in here somewhere. Let's right click. Values. There we go. Percentage. So it's in the values, and that's 12.5, so that's okay. Let's close that, and then we just got to do the same for the other ones. It's probably easier to edit them this way, or you can do it in the bottom left hand corner. So first off, for the airfoil, you've got to select the airfoil as the part that you're doing it on, and click OK. And then for the value, you're changing that to 5% of the base. So that's okay, close that. And then for the other ones, so the leading edge, edit, the part, leading edge, and then the value for that is percentage of the base. We're changing that to 1. And for the trailing edge, and the part, trailing edge, and then we're changing the value of that one to also be equal to 1. Okay. So you notice there we follow logic down because they're active and they've got a part associated with it. So now we're going to generate the mesh. So I'm going to save it first, and then I'm going to click the generate mesh. And that is whirring away in the background and it's creating this mesh. Of course, you can't see anything because we've not got a scene set up. So in order to view what's going on, we're going to create a mesh scene. And what we've done is we've set up all these things. So we've got our background mesh, this is our overset mesh, and then we've got refinement around the leading edge, and refinement around the trailing edge. And then also refinement around the airfoil itself. So the prism layers and system. So that's what we've been doing. And then there's an overlap as well. Okay. So that's wiring away in the background. Go down to scenes. Right click in scene and do the mesh. Once it's ready, it will load one up. Takes a little while. It's creating all in the background. It's creating all these meshes that we specified. Okay, there we go. So there's our mesh scene that we've created. And you can zoom in and you should see this the plot. Right then, what we're going to do now is mesh convert to 2D. In the convert region, tick the delete 3D regions after conversion. Click OK. Let's just create it in 2D. Yeah, let's save the simulation. And then we carry on. Specifying the angle of attack. So you can, unfortunately I can't zoom in on mine, but you can zoom in on yours. Rotate the overset region 2.54 degrees angle of attack. So let's go to regions, overset 2D. and down here there will be regions overset 2D, node, select, transform, rotate. So right click, transform, rotate. And then it brings up an angle, and we're going to set the angle to 0 radians. And we're going to change it to -2.54. Something big, so make sure it's in degrees. Then click apply, and you can see that's tilted the overset mesh. So click close. And on to the next one. Coupling the overset mesh, so we're going to couple this in with a background mesh. Okay, so to create this interface, multi-select the background 2D as well regions. So background 2D and then control overset, so we've got them both selected. Right click, and then we want to create an interface, and it's an overset mesh, and away it goes. And then we've got an overset one mesh node appears under interfaces. So we've got this new interface thing here, this overset mesh there. And it's user default distance weighted and interpolation option. And for the physics conditions. And we want distance weighted, yeah, so that's the default thing, so we'll put that as it is. And that couples them together. Okay, so I think that's all okay now. Carry on. And now to analyze the mesh, again you can zoom in, but what it wants is right click interfaces, select initialize, and it goes away and it's setting that up. Okay, now let's create a scalar scene. On scenes, we've got a mesh scene. Right click, new scene and new scalar scene. There we go. Right click the scalar bar at the bottom and display select overset cell status. So you can go down here and there should be an option overset cell status. Okay. And then we select scalar scene 1, displays, scalar 1, and set the representation to overset mesh. So that'd be in here somewhere. Representation volume mesh, and change that to the overset mesh. There we go. And that kind of gives us a scale of the status. And then first look at the cell status. Select scalar C1, displays, scalar 1 parts, and tick the Overset 2D region. Overset 2D. So that's selected. Let's deselect the background. Should be there. So there we go. Okay. And then there we go. So that's highlighting just that overset region. Next thing, select the scalar scene 1. Energy 1 display a scalar 1, a scalar field, and we will set the min to -2 and the max to 1. So the min -2, that's okay. Set the max to 1. Accept the cells, outline the overset region in blue, and so there we go. That's what, if you zoom in, that's what you'll have. And then to see the background region cells, change the parts. So this part, change that to background. Background 2D within the scalar scene. Scalar 1 parts node. Yeah, so there we go. I've selected the background. The red cell. Okay, so that hopefully that's what we should have. Okay. There we go. Okay. So that's set. That's okay. So just making sure that's all. Now we're setting up the physics. So we go back to the continuum. So geometry, continuum. We've got physics 1. So we can delete the physics 1. So right click, delete, get rid of that. Just left with the physics 2D. And it wants us to change this, rename it to L4. There we go. And now we can choose the physics models for this simulation. So if you right click, select models, in the space that 2D is already selected, we're going to run a steady state. We're going to have it's going to be a gas. It's going to be coupled, and gradient is automatically selected, and the equation of state is going to be an ideal gas, so it's going to be compressible. We're going to have it turbulent, and we're going to use the Scalar turbulence model, and I think that's it for all the models we need. So you can click close, and all those models will go in here. They're all in there. Right, now we're going to set the material properties. So we're going to look at this there. And we are going to change a few things. Dynamic viscosity. We're changing that method, keeping that as constant. but we're changing the value. That's 4.5. This is similar to what we did in the previous one. So 4.58. Well, that's it. 4.58. E to the -5. Thermal conductivity. Changing that value to 0.6. And then 3.8. You can type the full range in. I'm doing range in. Just put that in. That'll do. And then we're going to set the initial conditions. And we are going to change the velocity. And change that to 252 and 0. And so 252 in the x direction, 0 in the y. And the temperature is always 300, that's okay. Everything else is okay. Now we're going to look at the boundary conditions. So we've got regions, the background, boundary, and the outside physics values. And we're going to set that, so we've got the max number here. We're setting that to 0.725. And we're changing the temperature. I think that should already be 300. Yeah, that's 300. That's okay. That's the boundary conditions set up. Setting the solver parameters similar to what we did last time. So coupled implicit. I'm going to set that current number to 20 this time. So this is a stability parameter. Okay, we'll save the simulation and then move on to the next step. And prepare a scalar scene. So I'm going to go into scenes, right click, new scene, new scalar scene. Right click the scalar bar at the bottom. And we're going to set that to max number. And use, oh, I think that didn't work. Let me just check. Yeah, max number level isn't the same. Okay, good. And now let's save it again. And now we're going to initialize. So that's setting the whole thing to this max number of 0.7225. So it's all blue. And now I'm going to change the style of the max number contours. So we've got to go into Scalar 2. This is what we just created. And I'm going to change the display. The scalar. Click on Scalar. Change this to smooth filled. And now we're going to do a report to monitor convergence. So right click on the report, new report, go through that one and its force coefficient. This is similar to what we did last time. And we're going to rename that to drag curve. And now select the drag, and we're going to change the properties. So we've got the directions okay, but the density we're going to change that to 1.177. And the velocity, we're changing that reference to 2 by 2. And then the part, we've got to tell what part it is. So we can click on here, and it's the overset. These are the regions, overset, and it's beautiful. That's what we're measuring the drag on. Okay. And now you can right click this, create monitor and plots from the report. That's going to create this new plot for us. And you can repeat the steps to create the same one for lift. But you've got to change the direction to 0, 1, 0. So I'm not going to do that. I'm going to skip through that. Let's click save. But yeah, you can just repeat that for the lift. And now we're going to run it. I'm going to make this a little bit bigger because I've lost the button. There it is. Click run, and off it should go, hopefully. There's the simulation running. And it will run to the default of 1,000 iterations. And then what you should end up is something looking like that. So this, you can click and see what the drag coefficient is doing. When you set up the lift coefficient, you can also see that one. And then this is the scalar as it's going through. And if you zoom in, you can actually see a quick representation of what's happening. Okay. The next thing to do then is, so that's all running. And let it carry on a little bit so it stabilizes a bit. And then we'll change the angle. And that's just running away. What I'm going to do actually to save time and I'm going to change the angle before it's actually finished running. So it's running away. We're coming to a solution. It's going to, you could leave it running until this line goes perfectly flat, and then you know you've got a solution. I'm going to, like I say, I'm going to stop it there and change the angle just to save a bit of time. I click stop. And then that stopped the solution at 124 iterations. Let's just minimize that a bit. Okay, and then I'm gonna just save the results in there. And now I'm gonna go through. You can look at the results, zoom in, and you'll see this shockwave. If it's run properly, and the drag coefficient will look like this. But of course, I've stopped it early. I've stopped it somewhere around there. So let's move on. And I'm going to change the angle of attack. So let me go on to the. Oh yeah, I've got a zoomed out version of the mesh. So in order to do this, then we'll go back up to regions. And we go to the, let's minimize the background. So we've got the overset 2D node. You right click, you can set transform, and then it's rotate. And then what you can do, rotate it, you set the angle to minus 10 degrees. So minus 10 deg. Press return, so it's gone in. Click apply. That way it's And then what it's done is you can actually see on yours, it's actually changed that whole overset mesh, including the airfoil, to 10 degrees. And then you can rerun the simulation. So close that. Probably worth clicking save. And then rerun the simulation. I've got to expand my thing out again. Oh, hang on. In the menu bar, okay, so clear the solution first. So let's just clear. And then we'll run it again. That's a very quick and easy way, once you've got it, running the solution again. Click somewhere to get rid of, I don't know why, there we go. So just click somewhere to get rid of that. And then the airfoil's change angle, and the solution's rerunning. And you'll get a different result with a different angle. So a very quick way, using overset mesh of changing the angle. The other way to do it is, of course, we can actually change the inlet conditions and keep the airfoil where it is. Okay, so there we go. That's using an overset mesh. I'm going to stop the recording there.